Okay, so here we were studying about electric current. We have studied that. What is an electric circuit? Electric circuit is the continuous and closed path of electric current. Okay, the path of the charges are flowing in a closed path, that is the electric current is flowing in a closed path. So this continuous flow of the electric current in a closed path, we call it as this is the electric circuit. Okay, then we have studied that what is current. Current is the charge flown per unit time. Okay, so the charge flowing per unit time, we call it as electric current. Okay, then the conventional direction of the electric current here we have studied. Conventional direction is opposite to the flow of electrons. So opposite to the flow of electrons, we say that it is the electric current. Then the function of the switch. Switch is the conducting link between the cell and the electric bulb. Okay, between the cell and the torch bulb, the conducting link which is there, that we call it as the switch. Okay, now here today we'll study in detail about electric current. Okay, as discussed yesterday, electric current is charge flown per unit time. Okay, here the charge is represented by Q. So the charge flown per unit time. That is the rate of flow of charge. Rate of flow of charge is the flow of the charge per unit time. We call it as electric current. So I is equal to Q upon T is the formula. Charge is represented by Q. So current is equal to the rate of flow of charge, or you can say that it is the charge flow per unit time. Okay, here the SI unit of electric current is ampere. The SI unit of electric current is ampere. SI unit of current is ampere. Okay, so in SI system, we have studied in the lower classes. In class 9, I taught you that there are 7 fundamental units. Okay, 7 basic units are there. The first 3 are meter, kilogram and second. Meter, kilogram and second. In SI system we are talking about. Okay, besides these three together, NKS system it forms. Besides these 3, there are 4 more fundamental units. What are those? The next one is ampere. Ampere is for electric current. The next is Kelvin, which is for measuring temperature. Candela for measuring the luminous intensity, and more for the electrode loss. So these are the 7 fundamental units. So from here you see that the SI unit of electric current is ampere. So the SI unit of current is ampere. Okay, but the unit of charge is taken as coulomb. The unit of electric charge is taken as coulomb. So here 1 ampere is equal to 1 coulomb upon 1 second. If the charge flow is 1 coulomb, again this unit coulomb is taken in order to honor the sign is coulomb. Okay, we gave one law in electrocharge. So in order to honor the sign is the unit of charge is taken as coulomb. So 1 ampere is equal to 1 coulomb upon 1 second. That is when 1 coulomb of charge is flowing for 1 second, then the current flowing in that conductor we call it as 1 ampere. So 1 ampere is the current when 1 coulomb of charge flows for 1 second. Okay, now let's see what is 1 coulomb. 1 coulomb is equivalent to, it is equivalent to the flow of 6 into 10 raised to the power 18 electrons. Okay, as yesterday we have studied that only the electrons can flow through the conductor. The positive charges which are the protons, they are well inside the nucleus. Okay, so they cannot know what is going in a metallic wire. When we say that the current is flowing, charges are flowing, the electrons are flowing. So 1 coulomb of charge means the flow of 6 into 10 raised to the power 18 electrons. These many electrons if it flows, then we say that the charge is 1 coulomb. So from here we can find out the charge of 1 electron. What will be the charge on one electron? We need to record 1 coulomb is equivalent to these many flow of electrons. So 1 electron will have a charge of 1 coulomb upon 6 into 10 raised to the power 18. When calculated, this comes out to be 1.6 into 10 raised to the power minus 19 coulomb. So 1 electron has got a charge 1.6 into 10 raised to the power minus 19 coulomb. So how do we get this? The unit of charge is coulomb is unit of either it can be represented by capital Q or small q. The unit of charge is coulomb. Okay, and 1 coulomb of charge is equal to the flow of 6 into 10 raised to the 18 electron. So 1 electron will have a charge of 1 coulomb upon 6 into 10 raised to the 18, which when calculated it comes out to be 1.6 into 10 raised to the minus 19. So 1 electron has a charge of 1.6 into 10 raised to the minus 19 coulomb. Okay, and we know that electron is a negative charge. So the charge on 1 electron will be negative of 1.6 into 10 raised to the minus 19 coulomb. Or you may say minus 1.6 into 10 raised to the minus 19 coulomb. As the electron is negatively charged. Or you can say that it has a negative, one electron has a negative charge of 1.6 into 10 raised to the minus 19. Okay, so the current is the rate of charge, that is the charge time for the SI unit of current is ampere. Here 1 ampere is equal to 1 coulomb upon second. Now what is this coulomb? Coulomb is the unit of charge. Okay, and 1 coulomb will be equal to, it is equivalent to the flow of 6 into 10 raised to the 18 electrons. So from here we can find out the charge of 1 electron. So 1 electron will have a charge 1 coulomb divided by 6 into 10 raised to the 18 electrons. When calculated, it comes out to be 1.6 into 10 raised to the minus 19 coulomb. So 1 electron has got a negative charge of 1.6 into 10 raised to the minus 19 coulombs. Now let's read it. What is given over here? Page number 200. If a net charge Q flows across any cross section of a conductor in time t, then the current I across through the cross section is given by I is equal to Q upon T. So what is the formula of current? I is equal to charge flown per unit time, Q upon T. Okay. And how do we define electric current? Electric current is defined as, it is the rate of flow of electric charge. Or you may say that the charge flown per unit time. The SI unit of electric charge is coulomb. Coulomb, in order to honor the scientist, this unit is taken as coulomb, which is equivalent to the charge contained in 6 into 10 raised to the power 18 electrons. So the charge contained in 6 into 10 raised to the power 18 electrons will be equal to 1 coulomb. Okay, we know that electron possesses a negative charge of 1.6 into 10 raised to the power minus 19 coulomb. So how do you get the charge of 1 electron? 1 coulomb is equivalent to 1 coulomb of charges. The charge on these many electrons. So 1 electron will have a charge 1.6 into 10 raised to the power minus 19 coulomb. Okay, that is the electron. 1 electron is got a negative charge of 1.6 into 10 raised to the power minus 19 coulomb. Okay, then it is given the electric current is expressed by a unit called as ampere. Okay, and be represented by capital A, named after the French scientist Henri Marie Ampere. Okay, again this ampere unit is taken in order to honor the scientist Henri Marie Ampere, and that is why the unit of current is taken as ampere. Okay, this is also the name of the scientist. Coulomb is also the name of the scientist. So in order to honor the scientist ampere, the unit of current is taken as ampere. Small quantities of current are expressed in milliampere, where 1 milliampere is equal to 10 raised to the power minus 3 ampere, or in microampere, which is 10 raised to the power minus 6 ampere. Okay, if the current is very small, in an electric circuit, if the current is very small, then we have to use some smaller units of current. Okay, like milliampere or milli, we represent it by small m. And 1 milliampere is equal to 1,000 ampere. The relation is the same as between millimeter and meter. 1 millimeter is equal to 1/1000 meter, which can be written as 10 raised to the power minus 3 meter. The same way, 1 milliampere is equal to 1/1000 can be written as 10 raised to the power minus 3 ampere. So 1 milliampere is equal to 10 raised to the power minus 3 ampere. And if the current is even smaller units are required. Microampere. 1 micro, this is a fixed mu. Okay, and here this mu is represented for micro. 1 microampere is equal to 10 raised to the power minus 6 ampere. Okay, so milli we denote it by small m, micro we denote it by mu. 1 milliampere is equal to 10 raised to the power minus 3 ampere, whereas 1 microampere is equal to 10 raised to the power minus 6 ampere. Okay, so if the current is very small, we have to use this smaller units. An instrument called as emitter, which measures the electric current in the circuit. It is always connected in series in the circuit through which the current is to be measured. Figure 12.1 shows the schematic diagram of a typical electric current comprising the cell and electric bulb and emitter and a plug key. Note that the electric current flows in the circuit from the positive terminal of the cell to the negative terminal of the cell to the bulb and the emitter. Okay, now electric circuit diagram. Now what is a circuit diagram? Circuit diagram is, if we draw all the components in their symbols, okay, whatever components are there, using the components maybe an electric bulb, a cell, a battery, anything, okay, a switch, all these are the electrical components. Okay, now if we are drawing the diagram using the symbols of all these components, such a diagram we call it as a circuit diagram. Okay, now let us draw. First of all, the current is measured by a device called as emitter. Okay, the device is emitter which measures the electric current in the circuit. So if we have to measure the electric current in the circuit, we have to connect this device which is called as emitter. And the electric symbol for emitter is draw circle and written A. This is the symbol for the emitter and these are the two parts and the two terminals over here. Okay, when you come offline in the lab, you have to do the experiment also, in which you will use all these components, emitter, voltmeters, there you will see the cell, battery, key, all these things you will see in the lab also. Okay, so emitter, the symbol for the emitter is as shown. Okay, now here we draw a circuit diagram. Circuit diagram is, we will draw the symbols of all the components, whatever components are there in that electric circuit, will draw all the components and connect it to the bar. Make a closed circuit. This is called as a circuit. Now let us draw a circuit diagram which consists of a cell. This is a cell. The symbol for the cell is two parallel lines, one longer, one shorter. The longer line represents positive terminal and the shorter one represents negative terminal. If a number of cells are connected in series, that becomes a battery. This becomes a battery. Okay, then we connect. Let me connect the key. This is the symbol for the key. Okay, yesterday key of the switch, we have studied the function of the switch or a key. It is the conducting link between the cell and the other components in the electric circuit. Okay, then we connect an electric bulb. A bulb is there. This is the symbol for the bulb. And we have to measure the current. So we have to connect one emitter also to measure the electric current. So this becomes, these are the bars to which all these components are connected. Okay, so this is the emitter. This is the symbol of the emitter which is connected in this electric circuit, which measures the electric current. This will measure the electric current. Now this emitter also has got positive and negative terminal. And when you connect in the circuit, the positive of the emitter should be connected towards the positive side of the battery and the negative of the emitter should be connected towards the negative side of the battery. So the emitter is connected in this manner. It is measured in it measures the electric current and it is connected in series in the circuit. Now, what do you mean by series? See, all these components are in series. One after the other, all these components are connected. So, such a combination we call it as a series combination. Like here also, two cells are in series. That also battery. So, series combination means one after the other, all these components are connected. This is called as a series combination. So here we have drawn one circuit diagram, electric circuit diagram. Electric circuit diagram is using the symbols of all these components, we have drawn one diagram. So we have drawn a circuit diagram which consists of a cell or a battery, a key, a bulb, and an emitter. Okay, this key, when the dot is put in it, it means the circuit is closed. The circuit is closed means the circuit is completed and the current will flow in the circuit. Okay, what is the direction of the current? The conventional direction of the current here will be taken from positive to the negative terminal. Whatever current starts from the positive terminal, the same current will enter the negative terminal. So the direction of the current is taken from positive to the negative terminal in the external circuit. We are not talking about inside the cell. Okay, outside the cell, whatever components are there, in those components we are talking about. So in the external circuit, that is in the components which are connected externally, the direction of the current will be from positive terminal to negative terminal. Okay, so this is all about current. What we have studied, current is charge flow per unit time. So the formula for the current is I is equal to Q upon T. Okay, the unit of charge is coulomb and the unit of current is ampere. 1 ampere of current, 1 coulomb of charge thrown in 1 second. Okay, and 1 coulomb of charge is equivalent to 6 into 10 raised for 18 electrons. So these many electrons, 6 into 10 raised for 18 electrons will have a charge of 1 coulomb. So 1 electron will have a charge of 1 upon 6 into 10 raised for 18. That is 1.6 into 10 raised for minus 19 coulomb. And this charge is also negative. Why? Because it is the electron. Okay, the SI unit of current is ampere, but if the current is very small in the circuit, then we have to use smaller units like milliampere. 1 milliampere is equal to 10 raised for minus 3 amperes. Much smaller current, microampere, which is equal to 10 raised for minus 6 ampere. Then the current is measured by a device called as the emitter. And how is the emitter connected in the circuit? Is it connected in series? So here we have drawn one circuit diagram which consists of a cell or a battery, an electric bulb, an emitter, and a. Okay, so here we see that the emitter will measure the current and it is connected one after the other. All these components are connected, so it is connected easily. Also, when you connect it in the lab, you have to take care that positive terminal of the emitter should be connected towards the positive side of the battery, negative towards the negative side of the battery. And the direction of the current in the external circuit is from positive terminal to the negative terminal in the external circuit. That is to the external components, which are connected externally. Okay, so this is all about current we have studied. Now write down few questions. Hurry up, take out your copy and write down few questions I had given yesterday about switch, electric circuit. Okay, now write down define current and write its formula. Define current and write its formula. How will you define current? Current is charge flow per unit time, or you may write down the rate of flow of charge. And what is its formula? I is equal to Q upon T. So define current and write its formula. Write the next question. What is the SI unit of electric charge? What is the SI unit of electric charge? And find out the charge on one electron. And find out the charge on one electron. and find out the charge on one electron. Okay, how will you find out the charge on one electron? 1 coulomb of charge is the charge on 6 into 10 raised power 18 electrons. So 1 electron will have a charge 1 coulomb upon 6 into 10 raised power 18, which is equal to 1.6 into 10 raised power minus 19 coulomb. And as it is electron, this charge will be negative. Okay, write the next question. What is the SI unit? What is the SI unit of electric current? What is the SI unit of electric current? And define 1 ampere. And define 1 ampere. What is the SI unit of electric current? And define 1 ampere. Okay, what is the SI unit of electric current? It is ampere. And how will you define 1 ampere? 1 ampere is 1 coulomb of charge thrown in 1 second. 1 ampere is equal to 1 coulomb upon 1 second. Write the next question. Write down. Give some smaller units of ampere. Give some smaller units of current. Give some smaller units of current. Give some smaller units of current. Okay, what are the smaller units of current? It is milliampere and microampere, and also you will write how is it related. Write the next question. Name the device which measures electric current. Name the device which measures electric current. And how is it connected in the circuit? And how is it connected? How is it connected in the circuit? Okay, what is the device which measures the electric current? It is ammeter. And how is it connected? It is connected in series. Write the next question. Write down, draw a circuit diagram. Draw a circuit diagram consisting of a cell, or a battery, anything you can draw, consisting of a cell or a battery, a key, an emitter, and an electric bulb, Write one last question. Write down, what is the direction of electric current? What is the direction of electric current in an electric circuit? What is the direction of electric current in an electric circuit? Okay, written.